All right, Math 1, we are going to be starting section 5.3 on page 301. So if you want to go ahead and get your book out, we can go through this together. What we're going to be doing is comparing linear functions and exponential functions. A linear function, if you remember, is a straight line in the form of y equals mx plus b. And an exponential function, if you've noticed from the last section, it always has kind of a curvature. It starts out flat and then it raises quickly, and that's because of the exponent. Sometimes it decreases quickly because of the exponent. Now, the main difference I think they want you to understand here is what makes a linear line linear is that the rate of change throughout, it doesn't matter where you are on the graph in between any section. So if I section off like a little piece of the line, if this has a slope of, let's say, 1/2, then the section from here to here has a slope of 1/2. The section from here to here has a slope of 1/2. Even if I go from here all the way to here, it still has a slope of 1/2. It has a consistent rate of change. What makes an exponential graph, curve like this is because the rate of change between any points are going to be different. So maybe the rate of change right here might only be like 1/16th, but from here to here, maybe it's an 1/8. Maybe from here to here, it becomes like a negative or a positive 2. From here to here, maybe it's going to be a positive 8. All right, it changes consistently throughout the graph, and that's what makes the curvature. So what you're going to be doing today is just going through, they're going to be giving you information, they're going to be giving you tables, giving you graphs, giving you formulas, and they're going to be asking you, is it linear or is it exponential? All right, so down here, you have a table and you're looking for something consistent. Up on the top, we're going by ones. Down here, we're adding 2, 2 over 1, 2 over 1, 2 over 1. That is a consistent, that's linear. When it's in this form, obviously it's exponential because we have an exponent. It's not y equals mx plus b. All right, so if you look at the top of page 302, you have your table. This is consistently going up by ones, but here you are multiplying by 4. Anytime you multiply or divide, it is exponential. All right, so you're multiplying by 4. This is an exponential graph. It raises very quickly as you go up. You can see where the curve of the graph shoots up. That's because you're multiplying. Here it's going up by ones in the top, but you're adding 3s at the bottom. So it's, again, a consistent addition or a consistent subtraction, whichever one it is, you're going to have a linear function. All right, in real world things, you're going to be, again, if you're looking for something adding consistently or subtracting consistently would be your linear. If something is being multiplied or divided, you are looking at exponential. So Jack pays $30 each month for a gym membership. $30 gets added every month. That's linear. A culture starts with 1,200 bacteria and the number of bacteria is halved. Halved means it's exponential. You're dividing by 2. All right, the top of the next page. Each shirt sells for $15. That's a consistent 15. That is linear. Down here in the initial bacteria of 5 doubles every hour. Double means you're multiplying by 2. All right, so what you're going to be doing down here, they give you a formula for the rate of change in between any 2 points. So your A and B are the 2 points they're referring to, and you're going to substitute those in for the values here. Now, when it says f of b, it's really asking what is the y value once you insert the b. F of a means what is the a value when you insert the a, and then b and a just come from your what are the range that you're doing down here. All right, so let's flip over to the next page and go through this. All right, here's your formula. All right, I've written it right here. I am not going to be graphing these, but we are going to do the intervals. So in between 0 and 2 is going to be our first interval. So A is the 0, B is the 2. I'm going to input them into this equation and do the math. All right, so I'm going to use this equation right here. And I'm going to input. So my B was 2. I'm going to put 2 right here. 3 squared is 9. 9 times 2 is 18. So that's my f of b. All right, that's this right here. Now I'm going to take the a and I'm going to input it in. So I'm going to put 0 in here. 3 to the 0 power is 1. 1 times 2 is 2. Then on the bottom, I just actually use those numbers. 2 minus 0. All right, well, 18 minus 2 is 16. 2 minus that is 0. So the rate of change for the first one is 8. All right, so the rate of change in this first interval is 8. Now I'm going to go over here to the second interval, and this is now my A. This is going to be my B. So I'm going to take 4 first. I'm going to plug 4 in here. You take 3 to the 4th power, which is 81. Okay, so if you need to get your calculator, go ahead and do that. And then you're going to take it times 2, and you're going to get 162. I'm going to put the 2 in. Well, I already put 2 in earlier, and I got 18. All right, and then down here, I'm going to do 4 minus 2. All right, so we take 162 minus 18, and we divide that by 2. And so now my rate of change is 72. So over this interval, so in between when my x was 0 and 2, I had a rate of change of 8. In between when my x was 2 and 4, I had a rate of change of 72. All right, so it looks like it's an increasing function. So now I'm going to go do this one again. This is going to be my A. This is going to be my B. I'm going to put 6 in here. So take 3 to the 6th power times 2. We get 1,458. So 1,458. We already did the 4 from the previous one. We got 162. Then we do 6 minus 4. All right, so 1,458 minus 162. And we divide by 2. We get a rate of change of 648. So over these intervals, as you can see, as my x's start climbing, these are my x values, my rate of change gets bigger and bigger. That means it's increasing as it goes up. All right, so let's come down here to this one and do the same thing. Now, this was an exponential function. This is a linear function, y equals mx plus b. So my rate of change should be consistent over my interval. So I'm going to do the same thing. I'm going to go and I'm going to do it over the interval of right here. Okay, so I'm going to take 2, plug it in first. So if I put 2 in here, 4 times 2 is 8. 8 plus 1 is 9. Then I'm going to put 0 in here. 4 times 0 is 0. 0 plus 1 is 1. And then I'm going to put 2 minus 0. So I get 8 over 2, which is 4. All right, now I'm going to go to my next interval right here, and I'm going to plug in the 4 first and then the 2. So I'm going to plug 4 in here. I get 16 plus 1 is 17. All right, we already put the 2 in here, and we got 9. And that's going to be over 4 minus 2. Sorry, I'm writing right there. That's going to be 8 divided by 2, which is 4. Now I'm going to go to the last one, this interval right here. I'm going to plug the 6 in first. 4 times 6 is 24, plus 1 is 25. Again, I already did the 4. And then I'm going to do 6 minus 4. So I get 8 over 2, which is 4. So if you take a look at here's my rate of change over the same intervals as I did up here. The rate of change is consistent because this is linear. The rate of change here was consistently greater because it was increasing exponentially. All right. All right, so if you look over on page 305, here we go. It wants to know what is the average rate of change over this interval. I can tell you this is linear, so my rate of change is my slope, which is right here, 6. This better be 6. So you're going to stick the 2 in first. You're going to put 2 in here. You get 12. 12 plus 17 is 29. Then you're going to put 0 in here, which gives me 17. And then you put it over 2 minus 0. All right, so I get 12 over 2, which is 6. My slope is 6, which I knew that, because 6 is your m. That's your rate of change right there. Remember, this is your initial value. This is your rate of change. So right here, the condo fees are $225 a month. That is a linear function. The number of customers last month was 30. The number of customers predicted to double every month. That is going to be an exponential model if we were to do that one. All right. I think that is probably about it. I don't know. If you have any questions, I will put the homework on Google Classroom. And if you have any questions, just let me know.